Hello everyone, welcome back to Algo Daily. In this particular video we are discussing the LeetCode daily problem of grid game, and this problem we have to given a zero index 2D array of grid which is the size of 2 cross n, where grid of row and column represent the number of points at position of row and column r comma c on the matrix, and the two robots are playing a game on this matrix, and the both robots initially start from 0 comma 0 and we want to reach 1 comma n minus 1, and each robot may move to the right r comma c to r comma c plus 1, and this is the right one condition, and the downward condition is row comma c r comma c to r plus 1 comma c. And after we have to return, the first robot wants to minimize the number of points collected by the second robot. In contrast, the second row wants to maximize the number of points it collects. And after that we have, if both robots play optimally, we have to return the number of points which collected by the second robot. We have not collected from the robot 1, we have to collect only from second robot. So now let's look at their problem statement, and then we have to explain their example test cases. So here we have the first we have given a zero index 2D grid, and this grid is 2 cross n, and where grid is present of row and column, and this row and column represent the number of positions where the matrix is present here, and we the two robots we have to play on that game. And initially we have to start from 0 comma 0 to 1 comma n minus 1, and both robots start and end from these points. Okay, and now we have to find, now let's look at their first robot and second robot. Like the first robot move to the right side of 0 comma 0, and the second robot is also 0 comma 0, and the last one will be 1 comma n minus 1, and same for 1 comma n minus 1. And the second robot start, that we have to take care of second robot. The second robot starting at that point also move to the bottom right, bottom right. This bottom right is aiming to collect the maximum points which is remaining, and our goal is to compute the maximum points the second robot collect. Okay, this is our second robot which is collect if both robots choose the path optimally. We have to find where what we have to find, we have to find the path, optimal path, and the second we have to only choose for the second robot. So I hope you understand the problem statement. Like we have to find path and find the optimal path basically, and from robot 2 and the path. So now the path choice, the approach is we have to follow. First we have to choose the path. What path we have to choose first? We have to decide the row switch, and this row switch at any column to minimize the points available for the second robot. This is our second robot, and the second one is we have used to prefix and suffix sum, and this prefix and suffix sum from this prefix from top row and this suffix from bottom row. And now we have to calculate both robot paths from optimally by using prefix and suffix sum, and after this we have their optimal solution. For each column we have to calculate with the maximum points the second robot can collect if the first robot switches row to the columns. Like this is our robot 1 and this is our row side, and when it switches for column, then we have to find their optimal path. like what optimally we have to obtain. And the second one is we have to minimize the points the second robot can collect, as the first robot aims to minimize the score. And so now let's look at their example test cases for better understanding. So here we have this row 1 and row 2, and also we have given 0, 1 and 2 column. Okay, and so now let's look at for this one as a table form. First, this is our index value and this index, and here we have to use prefix sum. This is our top, the prefix sum of top row, and this is suffix sum of top row, now bottom row, and here we have to remaining condition of prefix, and here we have used for bottom remain, and here we have to calculate their max of top comma bottom. And now let's look at here. First we have to calculate this one value, so total here 5, 2 and 4, this is 11, and here we have 1, 5 and 1, this becomes 7. Okay, so we have to calculate the total of this one. And so now let's look at their follow-ups, like what index we have to follow. This is our index 0, this is 1 and this is 2. So index 0 we have their prefix value, the first value of 2, prefix of 2, and suffix is we have to follow this condition for int I is equal to m minus 1, I greater than is equal to 0, minus I, and this is our suffix condition for calculate the sum of these values. So suffix of this one is 7, and so now remaining is we have to follow this condition is prefix of m minus 1 minus prefix of I, and so this become is 11 minus 2, and so bottom row, this bottom remain is we have the total minus this one of prefix of I, suffix of 0 minus suffix of I. So the suffix of 0 is our 7 minus 7 is equal to 0, and this become 11 minus this is 9, so maximum of this one is 9 comma 0 is equal to 9. And after that we have their index 1, this index 1 value is of here 5, so so index 1 value is 5 plus 2, we have to follow up these condition 5 comma 2, 5 plus 2 is 7, so the remaining is here is 7. So the also we have to calculate the suffix value. So suffix value is we have to iterate with one to another position, so we have to decrease the value. So here we have 7 minus 1, so this becomes 6, so here 6, and the remaining prefix we have to got here 11 minus 7 is equal to 4. Okay, and so bottom becomes 7 minus this value 6 is equal to 1. So maximum of this one is 4 comma 1 is equal to 4. And after that our last iteration we have to follow the condition of first we have 5, 2, 5, 4, because we have to iterate for int I is equal to 0, I less than m plus 1, plus I. So here we have to iterate towards, here we have to backward. So this is the prefix and suffix sum approach we have to follow. So that's why here the index value is 2, the prefix value is become 11, and the suffix value of this one is last remaining is 1, and after that we have here 11 minus 11 is equal to 0, and here we have 7 minus 1 is equal to 6. Okay, and the maximum of this one is 0 comma 6 is equal to 6. And we have first we have what we are doing here. You can also be track the path like greedily. You have to use greedy approach for one to another path, then which position we have to follow, like this one, and so on. We have to follow the prefix and suffix sum for to calculate all the values from uh, forward and backward side. And prefix sum, we have to find their cumulative sum, like cumulative of prefix of I is equal to prefix of I minus 1 plus, here we have to follow grid of 0 comma 0 to I. We have to follow this one. And the suffix cumulative is suffix of I is suffix of I plus 1 plus grid of 1 comma I. So here we have to follow these two conditions of prefix and suffix. And now the remaining condition we have to follow. The remaining condition is we have to follow that this is our top, this is our bottom. Okay, so the top is we have to follow is prefix of m minus 1 minus prefix of I, and the bottom of this one is suffix of 0 minus suffix of I. Okay, so here we have this prefix and suffix is we have to follow here these two columns, and here the top and bottom we have to follow here these two conditions. You can also dry run for this one, for this example, like we have to explain this one. And so second one is we have to create again a table form. Here we have index value, here we have prefix, here we have suffix, here we have the top, the remain, so top remain, okay, top, and here is bottom remain, and here we have answer, this result. And first we have here the value is 0 0 1, sorry 0 1 2, 0 1 2, and so first we have to use this 0 1 and 2. So the index value we have to follow, and we have to first we have to calculate the total prefix and suffix value. So 3 3 and 1 is become 7, and here the become is 8 5 2 13 and 15, and this become 15. Okay, so now the prefix of this one is we have first value is 3, and the suffix value of this one is 15. We have to calculate 15, and the top value is 7 minus 3. First value is 7 and second is 15. So 7 minus 3 is 4, and the bottom value is 15 minus 15 is equal to 0, and the result is maximum of these two values is 4. And same for next iteration, we have index 1 value. This index 1 value we have to iterate all over the values, and thus here we have to follow this one. Okay, so here 3 plus 3 is equal to 6, and this becomes 6, and here we have to suffix this one. Prefix is start from this one, and suffix is start from last to first. So 5 plus 2 is 7, and so this become here this becomes 7 minus 6 is equal to 1, and here this becomes is 15 minus 7 is 8, and the maximum of this one is, so maximum of this one is 8. Okay, and after the last iteration, we have here 1 and 2. Okay, this second index, so that this second index we have the value of the total is here 7, and this become is like 8 minus 2 and so on. We have to compute the overall. Okay. So here we have 7 minus 7 is 0, and the top value we have to calculate here. That prefix of this one is, we have second, this 2, 7 minus 6, the prefix value 7, 1 second, and the suffix value of this one is 2. Okay, 1 second, 15 and 7. We have their optimal condition of, okay, we have become 2 here. And so here is 7 minus 7 is 0, and here is 15 minus 2 is equal to we have to got here 13. 1 second, I guess, yeah, 13, and after the maximum of this one is 13. So here we have to calculate the maximum of both these things. The maximum of minimum of these three values is 4. So the answer is 4. Answer is 4, you can say. And so now let's look at their exam coding part for understand how this prefix and suffix is actually work. So here first we have their create a prefix and suffix sum. This prefix and suffix sum for to find and calculate the top and bottom row, and the prefix of this is for our top row, and this is for our bottom row, and this answer is calculate these values. And now here we have to this minimum value we have to calculate the maximum points the second robot can collect for each switch point. So that's why we have to use minimum of this one, like suffix of 0 minus suffix of I and prefix of m minus 1 to prefix of I. We have also calculate here, like we have all these iteration from here, so we have to implement on that code. And so here the prefix calculation is to cumulative sum for each sum, and suffix for the cumulative sum for bottom row, and this is for top row, and this is for bottom row. And after this we have to find their optimal path, like update the result with the minimum, and we have to use find the minimum of prefix and prefix comma suffix, like this is top comma bottom. And now let's look at their time and space complexity. So the prefix of this one is O of taking O of n time, and same thing for this is taking O of n time. So the total time complexity, and this one also become O of m time, and the total time complexity of this code is O of n, and m you can say O of m. Okay, and the space complexity of this code is O of n, because we have to use prefix and suffix array. So I hope you understand the logic and the implementation part of this code. So thank you everyone, thank you so much.